Hello viewers, in today's session we are going to discuss an important type of indefinite integration in which the form is of this type, that is we have a quadratic function in the numerator and another quadratic function in the denominator under the square root sign, right? So here we have q1 as the first quadratic function and q2 is the second quadratic function, right? So here we'll see how we can integrate these type of integrands where we have q1 divided by square root of q2, where q1 is the quadratic function of the type ax square plus bx plus c, and q2 is another quadratic function of this type, say px square plus qx plus r, right? So we'll see how we can express this function, that is q1 over square root of q2, to get the indefinite integration of this function. So let us start. So the method to integrate these type of functions is that we express this q1 as a times q2, and then we have here b times the derivative of q2 and plus e, right? So if we take q1 as ax square plus bx plus c, then ax square plus bx plus c can be written as a times here q2 is px square plus qx plus r. Then we have here b times the derivative of q2. q2 is px square plus qx plus r, and then we have this term e, right, where a, b and e are the constants which are to be calculated, right? So a, b, c, e are the constants, right? So we'll express q1 like this, right? So now we can compare this integrand with this one. So q1 is our quadratic polynomial, that is x square plus x plus 1, and q2 is given by x square minus 1. So now let us write q1 as x square plus x plus 1, and here we have the constant a times q2. q2 is x square minus 1. Then we have b, and the derivative of q2. q2 is x square minus 1, and then we have here the constant e, right? So let us simplify this expression. So we have a times x square minus 1. Here we have b times the derivative of x square minus 1 is simply 2x, and here we have e. So now let us rearrange the terms here. So we have ax square minus a plus 2bx, and here we have e, right? So we have ax square, then we have 2bx, and then we can collect these two terms. So we have e minus a, right? Okay, so now we have the left hand side is x square plus x plus 1. Here the coefficient of x square is 1. Here the coefficient of x is 1. So comparing both the sides, the value of a is equal to 1, right? And the value of the coefficient of x is 2b, and here the coefficient of x is 1. So we have 2b is equal to 1. So b is equal to half, right? And the constant term, that is e minus a, is equal to 1. Now taking a is equal to 1 in this equation, we have e minus 1 is equal to 1. So e is 1 plus 1, that is 2, right? So finally, we have obtained the value of a as 1, the value of b as half, and the value of e as 2, right? So now let us substitute these values in this expression. So now x square plus x plus 1 may be written as a is 1. So here we have 1 x square minus 1. Then we have b is half. And here we have 2x and e is 2, right? Okay, so now we have x square plus x plus 1 is equal to this expression. So let us call this integral as I. So now we can write I is equal to the integral for x square plus x plus 1. We can write 1. Here we have x square minus 1 half 2x, and then we have 2 divided by square root of x square minus 1, and here we have dx, right? So now let us write this integral as a sum of three integrals. So we have I is equal to integral x square minus 1 over square root of x square minus 1. Then we have half and 2x over square root of x square minus 1 dx, and then here we have 2 times the integral dx over square root of x square minus 1, right? And obviously we have c as the constant of integration. So now let us calculate the values of these three integrals. So let us call it I1, this is I2, and this is I3, right? So I1 is integral x square minus 1 over square root of x square minus 1 dx. Here we have dx. So now we can write this integrand as x square minus 1 raised to 1 minus half and dx, because here square root of x square minus 1 can be written as x square minus 1 raised to half, right? So subtracting these two numbers, we have integral x square minus 1 raised to half dx, which can also be written as square root of x square minus 1 dx. So now this integral is of the form square root x square minus 1 square dx, and here we can apply a standard result, and the result goes like this, that is integral of square root of x square minus a square dx is equal to x over 2 square root of x square minus a square. Then we have minus a square by 2, and here we have a term containing the natural log. So here we have x plus square root of x square minus a square, right? So if we compare this term with this one, then the value of a is equal to 1. So here the value of this integral is now x over 2 square root of x square minus 1 square. 1 square is 1, 1 square is 1, so we have half, and here we have log of x plus square root of x square minus 1, right? So I1 is given by this expression. So now consider this integral I2. So I2 is a half, and here we have 2x over square root of x square minus 1 dx. Now we can solve this integral by method of substitution. So we can take t is equal to x square minus 1. So dt is equal to 2x dx. And now we can write half, and here for 2x dx we can write dt, and here we have square root of t. So this is half, and we can take square root of t to the numerator. So we have t raised to minus half dt. So this is half, and we can write it the integral minus half plus 1 over minus half plus 1. So this is half, and this is 1 minus half is half, so this is square root of t. And here we have half, so half and half get cancelled, so we are left with square root of t, that is square root of x square minus 1, right? So the value of this integral I2 is given by square root of x square minus 1. So now consider this integral I3. So here we have 2 times, then we have dx over square root of x square minus 1, which can be written as square root of x square minus 1 square, right? So to write the integral of this expression, we'll again use a standard result. So we have this important result, that is integral dx over square root of x square minus a square is given by the natural log of x plus square root of x square minus a square, right? So we'll apply this result to this one. So we have 2, and then we have log of x plus square root of x square minus a square. Our a is 1, so 1 square is simply 1, right? So the value of I3 is given by this expression. So viewers, this is how we can find out the values of I1, I2, I3. So now to get the value of this integral, we can add all these three integrals, that is I2 plus I1 plus I2 plus I3. So I1 is x over 2 square root of x square minus 1 minus half log of x plus square root of x square minus 1. Then we have I2 is square root of x square minus 1, and then I3 is 2 times log of x plus square root of x square minus 1, right? So now see here, we have these two like terms, so we can take square root of x square minus 1 common, so we have x over 2 plus 1, and then here we have again two like terms, so this is 2 minus half, and we have log of x plus square root of x square minus 1, and obviously here we have the constant of integration, right? So now we can rewrite this integral I as the square root of x square minus 1, x over 2 plus 1, and here we have 4 minus 1, that is 3. So this is 3 by 2 log, and here we have x plus square root of x square minus 1 plus c, right? So this is the required expression for the indefinite integral of this function, right? So this is how we can find out the indefinite integration of the functions of this form, or the integrands of this form, q1 over square root of q2. Hello viewers, in today's session we are going to discuss an important form of indefinite integration, right? So here in this class we are going to evaluate this indefinite integral which is of this form, right? So before moving further, let us quickly analyze this form of indefinite integration, in which the integrand is of this form q plus p cos x divided by p plus q cos x whole square, right? Where p and q are some real numbers, right? So now see, Here we have to evaluate this integral, and now if we compare these two integrals, then we can easily see that the value of p is 3 and the value of q is 7, right? So let us see how we can find out the integral of this function, and we'll consider the general method here. So let us consider this one, right? So whenever we come across with the integrals of this type, where see, here we have p and here also we have p, and here we have q and here also we have q, right? So we have q plus p cos x, and in the denominator, the numbers p and q are interchanged, and we have p plus q cosine x whole square, right? So we have to make an important substitution here. So let us take this substitution, that is t is equal to sine x divided by p plus q cos x, right? So whenever we come across with these type of integrals, we always take this substitution. So we should always remember this form of substitution while evaluating these kind of integrals, right? So here let us call this integral as I, and here we have p is equal to 3 and q is equal to 7. So our substitution in this case will take the form, that is t is equal to sine x, and in the denominator we have p plus q cos x, and here p is 3, so we have 3 plus 7 cos x, right? And we can also here visualize that this sin x is the derivative of this term, that is cos x, if we omit the negative sign, right? Because the derivative of cosine x is the negative sin x. So we can, for just for the sake of memorization, we can here visualize that this sin x is the derivative of cosine x excluding the negative sign, right? So now our substitution is t is equal to sine x over 3 plus 7 cos x. So let us differentiate both sides with respect to x. So we have dt over dx, and now here we have the quotient of two functions, right? So this function may be taken as u and this function may be taken as v. So here we'll make use of the quotient rule for differentiation, that is the derivative of u over v is given by v du over dx. Then we have u dv over dx divided by v square, right? So now we have u is equal to sine x, v is equal to 3 plus 7 cos x. So now we have 3 plus 7 cos x, and the derivative of u, that is sine x, is cosine x. Then we have here u, so u is sine x, and the derivative of 3 plus 7 cos x is minus 7 sine x, right? And in the denominator we have 3 plus 7 cos x whole square. So now we can simplify the numerator. So we have 3 cos x, then we have 7 cos square x, and then a minus and minus multiplied together becomes plus, and we have 7 sine square x divided by 3 plus 7 cos x whole square, right? So now we can take this expression, and we have 3 cos x, and here we can take 7 common. So we have simply cos square x plus sine square x divided by 3 plus 7 cos x whole square, right? So this is 3 cos x, and this is the famous expression for the trigonometric identity, that is cos square theta plus sine square theta is 1. So here we have 7 times 1 because this expression is equal to 1. So we have 7 times 1, 7. And here we have 3 plus 7 cos x whole square, right? So we have dt over dx is equal to this expression. And we can easily see that this is our integrand, right? So this is the integrand. So now we can write dt is equal to 3 cos x plus 7 divided by 3 plus 7 cos x whole square, and here we have dx. So now our integral it takes the form here this entire expression, that is 7 plus 3 cos x divided by 3 plus 7 cos x whole square dx. This expression is equal to dt, right? So we have simply here dt. And the integral dt is simply t, and of course here we have the constant of integration as c. So now our integral I is equal to t plus c, where c is the constant of integration and t is the substitution, right? So we have introduced this substitution. So now I is equal to sine x divided by 3 plus 7 cos x plus c, right? So this is the required integral, or the indefinite integral of this function. So now let us form another problem with the help of this problem, right? Suppose we want to evaluate this integral, that is 0 to pi by 2, and we have 7 plus 3 cos x divided by 3 plus 7 cos x whole square dx, right? So then what we will do, we'll first find out the indefinite integral of this function as we have discussed over here, right? And the indefinite integral is given by sine x over 3 plus 7 cos x plus c. So since here we have to evaluate the definite integral, so we'll omit this constant of integration. So we'll simply write sine x over 3 plus 7 cos x, and the limits are from 0 to pi by 2. So when we take here pi by 2, so sine pi by 2, and then we have 3 plus 7 cos pi by 2, and then we have minus sine 0, then we'll take this lower limit, sine 0 over 3 plus 7 cos 0. So this is sine pi by 2 is 1 and cos pi by 2 is 0. So this term goes to 0. So here we have simply 3, and here sine 0 is 0. So this entire term disappears. So we have simply 1 over 3, right? So the value of this integral is given by 1 over 3. So viewers, whenever we have an integral of this type, then we'll always make this substitution, right? Sin x over p plus q cos x, and the value of this integral is always equal to sin x, because see, here we have sin x, and the term is 3 plus 7 cos x. So here we have p plus q cos x, right? And c is the constant of integration. So the value of this kind of integral is always equal to sin x over p plus q cos x plus c. So from this discussion, we can now easily write down the values of these two integrals directly with the help of this result, right? So in the first case, the value of p is square root of 3, and the value of q is square root of 2. So the value of this integral is sin x, and divided by p plus q cos x. P is the square root of 3, and here we have root 2 cos x plus c. And in this case, the value of p is 5, the value of q is 8. So the direct value of this integral is sine x, and here we have 5 plus 8 cos x plus c.